Hello everyone. Today we are embarking on a fascinating exploration into the world of data structure. In this video, we will be delving into the challenges we have been faced during the daily life and solving those problems with the help of stacked data structures. By the end of this journey, you will not only understand how to tackle this problem efficiently, but also gain a deeper appreciation for the elegance and versatility of the stacked data structure. And also, this is the part two. You have, or you can also watch the part one of stack data structures. So, without any further ado, let's move on to the problems, solve them using stack data structure and Python programming language. Let's dive in. So, the first question we are going to discuss here is how to efficiently remove a middle element from a stack. We will be using Python and the stack data structure to tackle this challenge. So before going to the coding part, consider this as a stack of elements A, B, C, D, and E. This is a stack of size 5. So to find the middle element, we will have to plot divide the size of the stack with 2. So by this we will get the index number of the middle element. So here we get 2 as the index number of the middle element by floor dividing 5 by 2. So using by iterating using for loop, we will push all the last elements till the middle element into an uh, auxiliary stack that will contain E, D, and C. And from this auxiliary stack, we will use pop method to pop out the last element that will be C from the auxiliary stack. We will- So here the C will be popped out from the auxiliary stack. And again, the remaining these elements from the auxiliary stack will be popped out and pushed back into an original stack. So through this method, we will achieve the goal of deleting the middle element from the stack. So without any delay, we will move forward towards the coding part. So here I'm first going to create a class named stack. So the first function I'm going to create here is double underscore in double underscore. So this function is typically used for creating an empty stack cell code items equal to empty list. So after this, I'm going to create as function name is underscore empty. As the name suggests, it is used to check whether the given stack is empty or not. So here it will return length of cell or items equivalent to 0. So it will return if true if the length of the stack is 0 as the stack is empty, it will return true. Otherwise, it will return false if the stack length of the stack is greater than 0, it will return false. That indicates that the stack is not empty. So next function I'm going to add here is to push. The push. It is used to add items into the stack. Self, comma, item. So first self dot items dot append or item. So it will append the elements into the stack. The next function is for bracket self. It is used to delete the last element inserted into the stack. So for before deleting the element, we first have to check whether the given stack is empty or not. If not, self dot is empty is underscore empty. The function you have created above will be used here to check whether the given stack is empty or not. If it is not empty, we will return self dot items dot pop function bracket. So if it is not empty, it will pop the last element. Otherwise, it will not pop the last element. The next function we are going to create here is peak bracket self. So this is a function used to see the last element without popping them out from the stack. So for this function to run properly without any errors popping up, we will have to first check whether the stack is empty or not. If not, self dot is underscore empty function value. So it will check whether the stack is empty or not. If it is not empty, it will return self dot items or minus one. So the next function I am going to define here is the size function. So as the name suggests, it will return the size of the stack. That means the length of the stack. We have made, we have we have created the stack, then push pop. The last function we have to create is to check the size of the stack. So for checking the size, we have to return the length of self dot items. So it will return the length of the stack. So the class of stack is completed. Now move to the main part. The function we have to create here will be to delete the middle element. So the delete underscore middle in bracket we have to mention stack. So first we have to find the size of the stack. So for the size we have stack. Then we have to call the function above we have created stack of size function bracket. Then we have to find the index number of the middle element. So for that we have the size. Use of for division by 2, we will get the middle index number of the middle element. Then we have to create an auxiliary stack to store the last element till the middle element. So here's temp underscore stack equals to stack function right. So it will create an auxiliary stack to store these data, store the last element till the middle element. So the next using for by iterating using for loop for I in range of middle will iterate till the middle element. Then we have to push the elements into the auxiliary stack. Then stack dot push or stack dot or function bracket. So it will push the elements that have been popped out from the original stack. After that, the middle element will be popped out from the original stack dot pop function bracket. So it will pop out this middle element from the stack. So the next, after popping out the middle element, we have to use while to iterate. Well, no, temp stack is not only temp stack. No, while not temp stack, it's instead. While not temp stack, you have to use the function I have created above. That is temp stack dot is underscore the temp thing. So it will check whether the temp stack is empty or not, and it's creating a loop so that the stack get pushed with the remaining elements in the stem stack back into the original stack. So it will get backed up with by after removing the middle one. So then stack or push of them in this post stack dot of function bracket. So we have already deleted the middle element and the elements we have stored in the auxiliary stack will also get backed up into the original stack. So by this method, we will be achieve the goal of deleting the middle element. And for the main part, we cover underscore main cover underscore equals to cover underscore main cover underscore is equals to stack function bracket. Then as stored push, we have to just put some elements into the stack as it is already empty. So we have to push to check the program is working properly and randomly pushing some elements into the empty stack to restore push of going restore push of right. So now I am going to bring all these elements print original stack restore items. Then I am going to call the function delete middle to delete the middle element from the stack is and stack after the become this and so let's just run the program now. The original stack contains one, two, three, 4, and 5. And the stack after deleting the middle element will contain 1, 2, and 4, 5. The middle element 3 will be popped out from the stack. So the program is running by the I hope you understand this question. Now let's move on to the next one. So the next question we are going to discuss here is how to remove the middle element from a stack or to delete the middle element from a stack. Before going to the coding part, consider this as a stack of elements A, B, C, and D. D. So in this stack, we have to remove the bottom element that will be A. So to achieve this goal, we have to create an auxiliary stack. Here we are uh, following the same approach that we have used previous for deleting the middle element from a stack. So into this auxiliary stack, we have to push all the elements by popping out from the original stack and pushing at the same time pushing them into the auxiliary stack. So the auxiliary stack will contain D, C, B, and A. It is the reverse order of the original stack in is the auxiliary stack. So from the auxiliary stack, we use pop method to pop out the last pushed element, that is A. So after removing A, the remaining elements in the auxiliary stack will be pushed back towards the original stack. So after pushing the remaining elements in the auxiliary stack into the original stack, we will get the original stack as B, C, and D. So here the bottom element A has been removed from the original stack. So through this we can achieve the goal of deleting the bottom element from the stack. So without any delay we will move further towards the coding part. In this question also I am going to use some basic stack operations that have been previously used and also explained about it in some previous videos. So I am going to copy paste from the previous problem I have solved, that is deleting the middle element. So these are the some basic stack operations I have used in previous some problems. So these are functions that have been used to create an empty stack, to check whether the stack is empty or not, to push the elements into the stack, to pop out the last elements, to see the last element, and to check the size of the stack. So after these basic operations, I'm going forward to the main program. So the main function I'm going to define here is delete bottom function brackets stack. So first I'm going to create an auxiliary stack. Temp stack is equals to stack function bracket. And now I'm going to iterate through the loop by using y now stack dot is underscore 20 function bracket. Then I am going to push all the elements then underscore stack dot push of stack dot call function bracket. So it will push all the elements into the into the stem stack from the stack original stack. Next, I am going to pop the last element. So stem underscore stack dot pop function bracket. So it will remove the last pushed element from the stem stack. So now I am going to push all the elements back into the original stack while not temp underscore stack dot is underscore empty function bracket stack dot push of temp underscore stack dot pop function bracket. So it will pop all the elements from the temp stack into the original stack tag. So through this, we will achieve the goal of deleting the bottom element from the stack. Now, in the main part, I am going to write the double underscore name equivalent to double underscore main double underscore S equals to stack function factor. Then I'm going to push some elements into the stack, like one, store, push, of two, store, push, of three, store, push, of four, store, push, of five. And now I'm going to print the original state of the stack, like original stack before and deleting the bottom element. So let's dot items. And then I'm going to now call the function name delete bottom of s. And now I'm going to print stack of the deleted bottom element. Explore items. It will print the elements after removing the bottom element. Now I am going to run this program. The original stack contains 1, 2, 3, 4, and 5, and the stack after deleting the bottom element will contain 2, 3, 4, and 5. It is the easiest method to do this operations. I hope you understand the program and the logic behind the program very well. And that concludes our journey into the realm of stack manipulation. We have learned how to carry out basic problems and the implementations of stack data structure. From next video onwards, we are moving towards the queue and its implementations. I hope you found this video both informative and insightful. Until next time, happy coding and may your stacks always remain neatly ordered. Thank you.